Okay, this is a problem where we're adding sodium hydroxide, which is a strong base, to a buffer mixture that has some weak acid and its conjugate base ion. So I'm going to start by writing the equilibrium equation out. It's similar to the last one where I have formic acid and I'm adding it to water, and it loses its H to the water to increase the hydronium concentration and leaves the conjugate base ion of CO2H minus. And so we have some of this. We have 50 milliliters of 0.25 molar of the acid and 50 milliliters of 0.3 molar of the base. And so we have 12.5 millimoles of the weak acid and 15 millimoles of the conjugate base. And then it says we're adding the strong base. So we'll show the OH ions from the strong base being added, and it neutralizes either this, which is a weak acid, or this, which is a conjugate base ion. Because if we're adding a strong base, it's going to neutralize the acid. So we're going to show adding it to the acid molecule and then reacting completely to make water and the CO2H minus ion. And then we can figure out the amount of OH that's been added by doing 15 milliliters times 0.2 molarity, which gives us 3 millimoles of the hydroxide ion. And so this is going to go down by 3 millimoles, and this is going to go up by 3 millimoles. And so the buffer equation is the hydrogen concentration equals the Ka times the acid over the base. And so we need to look up the Ka of the formic acid, which is 1.8 times 10 to the negative fourth. And then we make the fraction of acid over base by starting with the 12.5 millimoles of the acid that we had in the buffer and the 15 millimoles of the base that we had in the buffer. And the acid goes down by 3 millimoles as the base goes up by 3 millimoles. And so we have a fraction of 9.5 over 18 times our Ka, 1.8 times 10 to the negative fourth, gives us our hydrogen concentration. And then we can negative log that to get our pH. And the pH here would be 4.02. Okay, thank you.